Good evening, everyone. Welcome to York Observatory Teletube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We're broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. Teletube broadcast every Wednesday night at 7:30 p.m. local Toronto time. And for any questions or comments you have about our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Twitter or Instagram with the handle at York Observatory and Facebook at Alan I. Carswell Obs. I am Matt, and I'll be one of your hosts this evening along with Maheen, Arfa, Dhyan, and Sergiy. Tonight, we've got a great presentation about the Crux, or the Southern Cross Constellation, as part of our Teletube Constellation series. But first of all, we wanted to mention that the observatory at your campus is in Toronto. And to welcome you to our show, we would like to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many indigenous nations. The area known as Sikaronto has been taken care by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat and the Métis. It is now home to many indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the First Credit Nation. And our stargazing and astronomical efforts are but the latest in a very long history of astronomy in this area. And before we get started with our main show, we want to give you a little update on what you can see this coming week. One of the first things that you'll be able to notice in the night sky is the star Vega. Vega is not only the fifth brightest star in the night sky, but the second brightest in the northern hemisphere. You could say that it is an important part of tonight's Teletube, not because it's part of the Crux constellation, because, well, it's not. As a matter of fact, Vega is the brightest star, yes, but of another famous constellation, Lyra. But then why is it important, you may ask? Well, the reason why it is important for this Teletube is because both the Southern Cross and Vega are important in navigation. I'm not going to say any spoilers so that you can enjoy the navigation part of this presentation, but I'll just say that in the past and in the future, Vega would be the way to look at it if north is what you want. Now, Vega is the second brightest in our hemisphere, as I mentioned before. So which star occupies the first place then? It must certainly be a massive one. And well, if you thought of that, then you're right. 100 times more luminous than the sun, Arcturus is the brightest star in the northern celestial hemisphere and the fourth brightest in the night sky. The guardian of the bear, or as it was known by the ancient Greeks since the year 700 BC, has other names that may not be as known as the guardian of the bear, which, by the way, this name in Greek mythology is Arcturus, reason why the star is named like that. But they are still really interesting and sometimes have a strong significance in the mythology and culture of ancient civilizations. In Chinese astronomy, Arcturus is part of the constellation of Jiaoxiu, or Horn Star, and its name is actually translated as the Great Horn, or Dajiao. As for the Inuit astronomy, Arcturus is called the Old Man, while for others it signifies joy, specifically the Star of Joy, as it was for the prehistoric Polynesia. And well, we can take this as a clear example that the stars as well as the constellations will have a different interpretation depending on the culture, civilization, and location as well. And the same goes for the Crux, or the Southern Cross constellation as we know it nowadays. So let's learn a little bit more about the history of this constellation, as well as the different interpretations and the stars that compose this constellation with the help of our co-host. But before that, let's check what is actually up in the sky right now with the help of our crew in Milky Way. They are right now in the 1 meter telescope. So take over, Milky Way. All right, it looks like we are getting, we're looking at a celestial object right now. I'm going to confirm.
We're currently looking at Arcturus.
Yeah, perfect. As I mentioned before, Arcturus is the brightest star in the northern celestial hemisphere. And our co-host today also prepared a lot of fun facts for the celestial objects that we'll be looking tonight. So if anybody else has a fun fact, please let us know.
Arcturus is a red giant star in the northern hemisphere, and it's also the brightest star in the Boots constellation. And currently, astronomers say that Arcturus will eventually end its life as a white dwarf. But right now, it's only about 1.5 times the size of the sun, so it's really not that big relative to the sun. And locating Arcturus, so the easiest way to locate Arcturus is by following the curve of the handle of the Big Dipper. And as you go down that curve, you'll see Arcturus, and then straight in line with that, you'll see the star Spica.
Thank you so much, Dhyan, for that fun fact. It is amazing to just think about the size or the mass of Arcturus being similar to the one of the sun, and still it being 170 times more luminous than the sun. Isn't that amazing? Does anybody have another fun fact that
Matt, you said that Arcturus is the brightest star in the northern hemisphere.
Yeah.
What about the southern hemisphere?
Well, if you know it, then go ahead.
Yeah, I looked it up, and it's actually Sirius. That's the
Wow.
brightest star in the southern hemisphere.
Well, to be honest, I wasn't sure. Now I know. Thank you so much. And do you know the luminosity for Sirius? Or is it way bigger than Arcturus and the sun, or is it as well like Sirius as well like Arcturus, that is similar in mass to the sun, but it is just more luminous?
Sirius is 25.4 solar luminosities, so it is 25.4 times as luminous as the sun.
Wow, that's amazing. And we're able to look at it right now. It's just amazing to use the 1 meter telescope and look at the stars. It leaves me out of words, to be honest. And does anybody else have a fun fact that you may want to share?
Actually, I have a question. So given the magnitude, the luminosity of this, the northern brightest star versus the southern, which one is the most brightest one then?
Well, it should be Arcturus in this case, because as Sergiy mentioned before, it was 25 times as luminous as the sun, the Sirius, while Arcturus is 170 times as luminous as the sun. So Arcturus is winning by a lot, but still Sirius is a pretty bright star in the southern hemisphere. And make sure to leave any comments or questions if you have any comments or questions on the YouTube comment section right now. And if you have any fun facts to share with us as well, you can share them with us right now in the comment section. Does anybody else of our co-hosts have any cool fun fact that you may want to share right now?
Sure. I'm actually gonna go ahead and share a bit about the origin of Arcturus. Seems like it's quite interesting. So Arcturus is actually thought to have formed outside of the plane of the Milky Way, which is in the outer reaches of the galaxy's thick halo. So some of the investigators have also posited that Arcturus may actually have been formed in a satellite galaxy that has since been devoured by the Milky Way, and that the 52 stars that share its motion and trajectory through the Milky Way are in fact the remnants of the galaxy. So I felt like that's quite an interesting origin.
It is, it certainly is. And another fun fact that I always share this fun fact when looking at Arcturus, but it is pretty amazing to me, is that Arcturus light was used to basically I don't know how this process worked, but there was like photoelectric cells involved, and its light was the one in charge of basically turning on everything in the Chicago's World Fair in 1933. So that's amazing. They chose a star, And the star, the light of that star is the thing that turned on every single light in the Chicago's World Fair. That is amazing, just to think about it. And there you can also notice that the star, even though it isn't as luminous as our sun for us because of the distance, it is still 170 times more luminous than our sun. So you can just imagine being at the same distance, at one astronomical unit of Arcturus. What I don't think, I'm not so sure if we would still be able to see something, or we would be blinded by it. But yeah, Arfa, you wanted to share one more fact with us. Go ahead.
For sure. Actually, I wanted to talk about the cultural significance or the name of the star Arcturus. So Arcturus is actually derived from the ancient Greek word, which means guardian of the bear. However, in the Arabic language, it has another meaning, but it still applies for this star, that is it al-Samak, or the uplifted one.
Oh, that's really interesting. I didn't know that. And Dhyan, go ahead, and you have another fun fact that you would like to share with us.
Yeah, so we all know that the universe is currently expanding. And because of that, Arcturus is on the move. Its current trajectory is actually bringing Arcturus closer to the sun.
Oh,
and
wow.
they'll be at their closest in roughly 4,000 years. But Arcturus will only be a few hundredths of a light year closer to us by that point. So it's nothing to worry about. As in its luminosity burning us up and everything. Like, we don't really have to worry about that. But yeah.
Well, that's good to know. At least we don't have to worry about that. Well, and as a matter of fact, it's already relatively close. It is at 36.7 light years away from the sun. So we could say that we are close, and that could add up to the fact that it is the most luminous star in the northern hemisphere. Not only the luminosity itself or the mass of the star, but also the distance affects the way that we look at it from Earth. And does anybody would like to share another interesting fact about Arcturus?
It does look pretty nice today. I feel like the weather is quite nice. It's very clear. Like the star is very nicely visible, so it's definitely nice to look at.
Yeah, honestly, it looks amazing, and the weather did allow us to look at it this way. It's not cloudy, even though there was a huge storm yesterday. We were kind of a little bit worried about it, and to see if the observatory itself was affected by the storm yesterday, but I don't think it was. And well, the most important thing is that we have really good weather, and it's a perfect timing for the Teletube tonight. So
yeah, I was really not expecting for us to have live imaging tonight because of these storms going on.
yes,
Yeah.
but it is amazing. It is amazing just to have the live imaging available for us. All right, I think that we are moving. In fact, we're moving to the star Polaris, which is, if I'm not mistaken, right now it is considered to be the North Star, and that will be the same for at least 13,000 years more. And then Vega will take over as the North Star again, as it was before. Normally, the North Star will change every 26,000 years. So we could say that Polaris has been the North Star for at least 12 or 13,000 years by now. We're able to look at it. It looks amazing right now. Does anybody have any fun fact that you would like to share about Polaris?
you can talk about Polaris for hours upon hours. Let's shorten that and describe it in a couple of minutes. So if you're in the northern hemisphere, your latitude is actually the same as the altitude of Polaris. It's simply mathematical equation. It's just 1 = 1, right? So the LNI Carswell Observatory is in Toronto, and since in Toronto Polaris is around 44 degrees from the ground, Toronto's latitude is also 44 degrees north. It's really easy to find out your latitude just by calculating the angle of Polaris to the ground. Another fun fact about Polaris is that Polaris is actually the short form of the New Latin phrase Stella Polaris, which means polar star. New Latin, if you didn't know, was not the Latin that the Romans spoke, but rather was used for scientific works ever since the 16th century. Most people know about Newton's famous Principia Mathematica, right? So that book is actually was written in Latin, unlike his later book Optics, which was written in English. But that book, Principia Mathematica, was written specifically in the New Latin variety. Does anybody else have any other interesting facts about Polaris?
Yeah, since we are having a Teletube today on constellations, I thought it should be mentioned what constellation it is a part of. So Polaris is actually 430 light years away and is located in the constellation of Ursa Minor.
Adding up onto the fact, Polaris is actually a yellow-white supergiant star, and it is located about 430 light years away, as mentioned by Maheen. So it has an apparent magnitude of 1.97, making it the 48th brightest star in the sky. And if you cannot find Polaris, although it's a North Star, you can find it using the other star around it, for example, Dubhe and Merak, to point it directly to the Polaris.
Thank you so much for those amazing fun facts. And we're trying to lower or increase the exposure here right now at the 1 meter telescope in order to be able to see the star, and especially the binary star that comes with it, because it is a multiple star system, as a matter of fact. And we're trying to look at the binary star that is with Polaris right now. We were talking about luminosity before, and I wanted to know, I don't know if you guys know, but I wanted to know, what is the luminosity for Polaris, and how would it be compared with Arcturus and Sirius that we already talked about them during this live imaging?
Well, I think it is 2,500 times brighter than the sun. I don't remember the exact numbers for the Arcturus, but it is way, way brighter than our own sun. And if you're talking about mass, it is 4.5 times the mass of the sun. And the star type for this one is F-class supergiant. So I'll be talking about the star types, or the stellar classification, the spectral in our future slides. But hold on to that. It's an F-class supergiant.
Oh, look at that. Look at that. I think we're able to see. It's a little bit dim right now, but we are able indeed to see the binary star that is right next to Polaris. It's right there. Yes. Thank you, right now, for pointing it us right now.
It seems quite distant actually in the image.
All right, we're trying to zoom it out and zoom it in so that we can have a better view for the binary star that is with Polaris. Oh, that's better. That's certainly better. And we are going to be trying to go to another celestial object right now. since the weather allows it, we're going to try to go through different celestial objects and talk about them with you right now. Yeah, that looks amazing.
Yeah,
Anybody? Yeah, go ahead.
Aren't stars supposed to be a infinitely small points of light? Why is it that the star is larger than that? Like, is that ideal? Is that supposed to represent it, or is that a flaw of the telescope?
So Professor Ida is actually answering your question here on the chat. Thank you so much, Professor Hyde, for adding that piece of information. It's due to atmospheric diffraction, according to Professor Hyde. Thank you so much for that answer. And the size of the image will depend on the system as well. So thank you so much, Professor Hyde, for that that answer, which, as a matter of fact, I would have had the same question that Sergiy had. So thank you for that interesting question as well. I think we're moving to another celestial object right now. All right, and yes, we are actually in Deneb right now. We moved to Deneb. Does anybody have any interesting fun facts about the star Deneb? Look at that! Wow, that looks amazing.
Since we were talking about luminosity between all of the other stars, Deneb's luminosity is 196,000 solar luminosities.
Really?
So it's really quite bright.
Wow, that's a lot of brightness. And another fun fact about Deneb is that it is the farthest and the brightest of the first 30 brightest stars in the night sky. So distance is approximately 2.615 light years, or you can say 802 parsecs away from the sun. And its diameter is more than 200 times of that sun, while its radius is around 203 solar radii. Another fun fact about Deneb is it is actually from the Latin word, which means the tail.
All right. Thank you for that fun fact. And yes, you know that this Teletube tonight is going to be about a constellation, specifically the Southern Cross. And Deneb is part of another important constellation. It's part of the constellation of Cygnus, as it was mentioned. And it is actually, I just looked up for it, and it's actually the 19th brightest star in the night sky. So it is really bright, but it is not as bright as Arcturus and as Vega that we mentioned before. Go ahead, Arfa. I think you have another fun fact that you wanted to share with us before we continue with our main episode.
Sure, thank you. So Deneb is thought to be about 10 million years old. However, scientists are not sure about its age until now. However, they predict that it is going to die and it's in its last stages, but no one is certain about it yet.
All right, thank you. And let me just double check with the crew at Milky Way if we are able now to continue with the actual Teletube, or do we have another celestial object that is available for us right now in the night sky? All right, so it looks like we're gonna take over. The Teletube is going to officially start. Thank you so much to the crew in the 1 meter telescope at the Alan Carswell Observatory. So we're gonna continue with Maheen. Thank you so much, Maheen, for letting us know this. Go ahead.
Thank you, Matt. I will now start us off with an introduction of the constellation Southern Cross. The Southern Cross, also known as Crux, is a constellation in the Milky Way of the southern sky, centered on four bright stars in a cross-shaped or kite-like asterism. The name Crux is the Latin for cross as depicted by its shape. Although the smallest of 88 modern constellations, it is the most easily distinguished due to its star's apparent visual magnitude, which will be discussed in later sections. Crux is bordered by the constellation Centaurus, which surrounds it on three sides, that is, the east, the west, and the north. The constellation Myska borders it on the south. Crux covers 68 square degrees and 0.165% of the night sky. Crux is exactly opposite to Cassiopeia on the celestial sphere, and therefore cannot appear with it in the night sky at the same time. It can sometimes be confused with the nearby False Cross by stargazers. False Cross itself is larger and dimmer and does not have a fifth star. It also lacks two prominent nearby pointer stars. The constellation known as the Southern Cross has been important for a very long time to the indigenous people and other cultures in the Southern Hemisphere, playing a key role in navigation as well as storytelling. Another recorded example of the discovery of the Southern Cross was around 1000 BC. It was plainly visible everywhere to indigenous civilizations in what is now the United States, as well as in ancient Greece and Babylonia during that time. Many ancient cultures of North America may have once used this interesting pattern. Although it is out of our field view now, even in 1000 BC, however, it would have been low in the night sky. At the time, it was identified as being a part of the constellation Centaurus by the Greek civilizations and is thought to have been used by ancient Mississippian civilizations of North America. Thought to have been located near the modern-day St. Louis in the United States. Due to the precession of equinoxes or the slow shift in Earth's axis, it gradually lowered below the European horizon and became visible primarily in the southern latitudes. Crux fell into anonymity for most in the northern hemisphere until the early 15th to the early 17th century. This is when it was rediscovered by the Europeans, Portuguese being among the first Europeans to map and rename the stars for navigation uses while rounding the southern tip of Africa. Crux was also separated from Centaurus during this time. It is amongst the most recognizable constellations in the southern hemisphere and is the smallest of the 88 modern constellations. It is prominent in several mythologies in southern hemisphere. Interestingly, the Southern Cross has been depicted on the flags of several different Antipodean countries. It can be found on the national flags of Australia, New Zealand, Papua New Guinea, Brazil, and Samoa. New Zealand's flag depicts only the four brightest stars of the cross, while all other flags also depict the fifth star, known as Epsilon Crucis. It has also been used as an insignia on the stamps of many Southern Hemisphere nations. It is included in the national anthems of both Australia and Brazil. The first Europeans to sail into the southern seas interpreted the four stars that had just come into the view as a cross, naming it Crux Australis, or the Southern Cross. According to T. Era, the Encyclopedia of New Zealand, in New Zealand, tribes such as Maori had varying traditions about the constellation. Tainui Maoris saw an anchor in the four stars, while Maori from the Wairarapa saw the outline of a plug through which storm winds blew. Very significantly, the Southern Cross has been a part of Australia's indigenous cosmology for millennia. The indigenous people of Australia have lived for well over 40,000 years on the Australian continent, and their descendants still enjoy the wonderful spectacle of the Milky Way galaxy directly overhead. In that long period, they built an astronomical knowledge system that is possibly one of the oldest in the world, as possibly some of the first humans to name celestial objects. Many different Australian Australian cultures had names and uses for this fascinating star group. According to Peto et al. 2006 and Walker 1972, the late indigenous poet Get Walker documented one of the original names for these stars as Mirabuka. For these stars in the publication, Ket Walker also documented as describing Biyami, the good spirit in the sky, who decided that he needed the assistance of someone to help him in the guardianship of his people. He chose a man named Mirabuka, who was not only loved by everyone, but also looked after the welfare of his tribe. So Biyami gave him a spirit form and placed him in the sky among the stars and promised him eternal life. Biyami gave Mirabuka lights for his hands and feet and stretched him across the sky so that he could watch forever over the tribes he loved. And the tribes could look up to him from the earth and see the stars, which were Mirabuka's eyes gazing down on them. We commonly still use the Southern Cross, but this is a very, very recent renaming by all accounts. The constellation Crux, like many other constellations, played an important role in the belief system of many cultures. The Incas knew the constellation as Chacana, which means the star, and the stone image of the stars was found in Machu Picchu, Peru. The constellation was known as Tipunga, or the anchor, due to the important role it played in maritime navigation. To the indigenous people of Australia, the Cross and the Coalsack Nebula, which Sergiy will talk more about later, together represented the head of Emu in the night sky. This mythical bird is associated with several indigenous creation myths and is also one of the most important constellations in their astronomical traditions. This significance led to the constellation's presence on the flags of several countries, as mentioned earlier. The significance of this constellation to many people and the history of astronomy is huge, but it wasn't just there to look pretty. Up next, Sergiy will tell us about one of the ways these stars can be very useful.
Thank you for the excellent presentation, Maheen. For thousands of years, the inhabitants of Earth have looked up into the sky and realized that the stars are useful for navigation. Just as the Southern Cross has been used to navigate the Southern Hemisphere, so can we navigate the world using stellar objects. Due to the precession of the Earth, the stars in both the Northern and Southern Hemisphere will shift over time, so the navigators of the future will have to shift their navigation to reflect these changes as well. There is a misconception that where the sun rises, it's true east, and where the sun sets, it's true west. This is only true at the vernal equinox on the interval of the 19th to 21st of March, and the autumnal equinox on the interval of the 22nd to 24th of September, so only 2 times a year. Any other time, due to the axial tilt of the Earth, the position of the sun is only an approximate. Another star, besides ours, that is useful for navigation is the leading star Mintaka on Orion's belt, which rises at true east and sets at true west if you're near the equator. Another tip includes lining up 2 sticks with a star and putting the 2 sticks 3 feet apart from each other. If the star appears to go up, you're facing east. If the star goes left, you're facing north. And this is true for every other combination. So if the star goes diagonally down and to the right, you're facing the southwest. If you're in the Northern Hemisphere, compared to the Southern Hemisphere, finding the direction to one of Earth's poles is very easy. If you want to find Earth's geographic North Pole, don't use a compass, as it will give you the direction to Earth's geomagnetic North Pole. Instead, find the brightest star in Ursa Minor, the North Star, Polaris. Polaris will be useful in showing where North is for 13,000 years until it is replaced by Vega as the North Star. To find it, follow Dubhe and Merak in the Big Dipper, Ursa Major, 5 times the distance of the 2 stars. Unlike the ease of finding north by finding Polaris, to find south, it'll be a bit more complicated. By following Orion's sword down to the horizon, one can find where south is in the Northern Hemisphere. On the other hand, if you're in the Southern Hemisphere, there are 2 ways to find south using the Southern Cross. You can either extend 4.5 times the length of Crux, then straight down to the horizon, Or you can locate two bright distinct stars to the side of the Southern Cross called the pointer stars, which always point towards the Southern Cross. And by using the two pointer stars, draw a line between them, and then draw a perpendicular line until it reaches the line from the Southern Cross if you extended it. At the intersection, draw a line straight to the horizon, and that's approximately south, more or less. Similar to how Polaris won't always tell you where north is due to the position of the Earth, these navigation tools will have to be adjusted in the future. The dual box cluster, or the Kappa Crucis cluster, or the even easier to remember NGC 4755, is an open cluster that can be found on the western border of Crux. It is approximately 6,440 light years away from Earth with an apparent magnitude of 4.2. If you look up at the sky in the southern hemisphere, it is visible without the need of a telescope, but it will look like a fuzzy star in the sky. It covers an area of 10 arc minutes and is pyramid shaped. To find it, just go a degree to the southeast of Beta Crucis or Mimosa. This star, Mimosa, will be discussed soon with other notable stars at the Southern Cross. Compared to other open clusters, the jewel box is very young, with an estimated age of only 14 million years. It is about 20 light years across and contains just over 100 stars. Open clusters such as the jewel box cluster are loosely bound groupings of stars. The stars are born from nebulae, and these open star clusters may be so young that they're still surrounded by it. Although it was known by many indigenous people before Lequet for many millennia, Nicolas Louis de Lequet is given all of the credit for its European discovery. He was a French astronomer who independently discovered the jewel box cluster in the Cape of Good Hope in South Africa on March 25th, 1752, being the first from Europe to realize that it was a cluster and not a fuzzy star called Kappa Crucis. The cluster, in addition to all of its other names, is also sometimes named Herschel's jewel box. This is due to the fact that it was given its current name, the jewel box cluster, by the English astronomer John Herschel, who had determined the position of 100 stars in the cluster. He described the cluster as brilliant, beautiful, and vibrant due to its differing colors of its stars. He described it as a, and I quote, casket of various colored precious stones, end quote. This was due to the fact that one of its brightest central stars is a red supergiant, in contrast to the surrounding ocean of blue stars around it. Some of the cluster's light is blocked by the Coalsack Nebula, and due to this, it is difficult to determine with a high amount of certainty the exact distance of the jewel box. In indigenous Australian astronomy, the Coalsack Nebula represents the head of an emu, with the constellation being made up of dust. In Incan astronomy, it is known as the bird Tinamu, which you can see on the screen right now. It has been important for the people of the Southern Hemisphere for more than 40,000 years. The Coalsack Nebula, along with Crux, was independently discovered by the etymological origin of what we now call the Americas, Amerigo Vespucci, on his second voyage in 1501 to 1502. The Coalsack Nebula isn't just a part of Crux, rather some portions of it are a part of neighboring constellations, namely Centaurus and Musca. A similar nebula, its northern equivalent, the northern Coalsack, can be found in the constellation Cygnus. Did you know, in astronomy, Coalsacks refer to very dark spaces in the Milky Way that are nearly void of any stars and thus any light? The Coalsack Nebula covers an area of around 7 by 5 degrees between the stars Acrux and Bcrux. Now, Dhyan will give us further details on the individual stars of the Southern Cross, such as Acrux and Bcrux.
Thank you, Sergey, for the excellent presentation. And now I'll be talking more about the main stars in the Southern Cross. So in the Southern Cross, aka the Crux, there are 5 main stars. These stars are named Acrux, Mimosa, Crux, Imai, and lastly Dhyan, which lies on the inside of the cross. These stars are scientifically known as Alpha, Beta, Delta, Gamma, Epsilon, Crucis. Now let's get into the details of these stars. Acrux, or Alpha Crucis, is the brightest star in the constellation. It is about 10.8 million years old, and it has a beautiful bluish color. And not surprisingly, this star is not a singular star. In fact, It is a triple star system where the two inner stars orbit each other while an outer star orbits the binary. The two inner stars are known as Alpha 1, and combined, they have a luminosity of 25,000 times that of the sun. And they have masses of 14 and 10 times that of the sun, respectively. The two stars orbit each other at a distance of about 1 astronomical unit, and they complete an orbit every 76 days. And that is really fast relative to our Earth's orbit around the sun, which takes 365 days to complete. The outer star that completes the trinary system is known as Alpha 2, and its luminosity is about 16,000 times that of the sun. And its distance from the two stars that it orbits at is about 430 astronomical units, or 430 times that of the distance between the Earth and the sun. And it takes Alpha 2 about 1,500 days to complete an orbit around the binary star. For more information about this, see our previous episode on Alpha Centauri. And there are many interesting theories about what could happen at the end of Alpha 1's lifespan. Because these two stars are so close to each other, when the more massive star does go supernova, it could completely blast the other star right out of the system. And now moving on to Crux, aka Gamma Crucis. Crux is located at the top of the Southern Cross, and it's very different from its peers as it does not emit a bluish white light. It is actually a red giant. In fact, it is the closest red giant to us at about 88.6 light years away. And being a red giant, it's not surprising that this reddish orange star is more massive than our sun. In fact, it's about 50% more massive than our sun. But it's not as hot as our sun. It's much cooler than our sun, having an average temperature of about 3,626 Kelvin. The temperature and the color of a star, in fact, do have a direct correlation because the surface temperature of a star determines the color it emits. Blue stars are hotter than yellow stars, which in turn are hotter than red stars. But unfortunately, other than that, not much is known about this beautiful star, mainly because of its location in the southern hemisphere, where in truth there have not been very many telescopes. And next, we go on to another charming star known as Imai, or Delta Crucis. This is also a bluish white star, the fourth brightest star in the constellation, and it is about 345 light years away from Earth. It's relatively smaller compared to the other two stars in the constellation, but it is still 8.9 times the size of the sun. And it has an average temperature of about 22,570 Kelvin, which is really hot. The cool thing about this star is that it has stopped hydrogen fusion or hydrogen burning in its core. And this is the dominant process that generates energy in the cores of stars. And currently, Imai is in the process of becoming a red giant. Unfortunately, it won't have an explosive end as it's not a supernova candidate, but it will eventually become a white dwarf star. Imai has a relatively fast rotational velocity at about 210 kilometers per second. And just for comparison, Earth's rotational velocity is only about 460 meters per second. The rotational velocity of an object is the turns per unit of time around its axis. So for example, Imai turns a distance of 210 kilometers per second around its axis. And lastly, Imai's age is estimated to be around 18.1 million years old. And next, I'll be passing it on to Arfa for more information on the other stars that are part of the Southern Cross.
Thank you so much, Dan, for such an interesting information about the three stars. I'll be talking about the other two. First, we have Dhyan, also known as Epsilon Crucis, the star that can be located between the two-star Acrux, that's at the base of the cross, and Imai, which is on the right side of the asterism. It can be spotted as an orange giant star that is considered to be the fifth star of the Southern Cross. Talking about the star's stellar classification and features, it is a K33 orange star. As I'm talking about the star spectrum here, let me tell you a little more about the spectrum. A star spectrum contains information about its temperature, chemical composition, and intrinsic luminosity. The spectral sequence go through O through M that represents stars of essentially the same chemical composition, but of different temperatures and atmospheric pressures. The spectral sequence is also a color sequence. The O and the B type stars are interestingly the bluest and the hottest. The M, R, N, and S type stars are the reddest and coolest. There are more details to the spectra, which I hope we can explain in our future Teletube episode. Now back to the star Dhyan. Dhyan is 1.52 times bigger than our sun in terms of the solar mass and has expanded over the past million years to 28.41 solar radius. Dhyan temperature is estimated to be around 4,294 kelvins, while the temperature of the sun is 5,778 kelvins. So it means it's cooler. However, Dhyan shines with a luminosity 302 times of the sun, but it is classified as an irregular variable star. The magnitude ranges from 3.4 to 4.0. Dhyan is a 2.17 billion old star. The little history of this star is, it started as a class A, bluish-white main sequence star, but since it ran off its supply of hydrogen, it started expanding and became a giant. Well, this star is moving towards the solar system at a radial velocity of minus 4.6 kilometers per second, which actually means that it's moving away from us. Dhyan has been and is used to find several other open clusters around it. For example, NGC 4439, NGC 4103, and NGC 4349. So whoever has a telescope or uses the telescope near the equator or the southern hemisphere learned a new trick on how to spot these clusters more easily. Unfortunately, due to the axial precession, the star which was once visible from mid-northern latitudes is only visible below the horizon for most of the northern observers. The star is invisible to the northern observers, but if you live at the south of the equator, you might get lucky to see this beautiful southern cross and the stars. A fun fact about the star: the name Dhyan is from the culture of the Vardaman people of the Northern Territory of Australia. This name is traditionally used there, but did you know the name actually refers to a dilly bag containing special songs of knowledge, or also the bag of songs in Vardaman creation mythology? Mimosa. Nope, I'm not talking about the drink here, but an actual star in the Southern Cross. Mimosa, it's an interestingly named star, and it was actually not given this name by the classical astronomers. This star is formerly called Beta Crucis and is ranked as the second brightest star of the Southern Cross. This name is thought to have been suggested by the German astronomer John Bayer. It is unclear about the reason why he suggested the word mimosa, but some suggest it was because of the star's blue-white color. It is found to be at the most left side of the cross. Being the second brightest star in the cross, it is actually ranked as the 19th brightest star in the sky. Again, the star is invisible from the northern latitudes, so you will have to pack your telescopes and go all the way to the southern hemisphere if you want to see this beautiful blue-white star. It is part of the southern constellation, and you cannot see it north of 30° north latitude. This star is about 253 light years away from Earth, and this data was collected by the Hipparchus mission. The second brightest star is a visual magnitude of 1.25. It is a giant, or sometimes also categorized as subgiant. This blue star is spectral classification of B0.53, making it 3,000 times brighter than our sun. Although the star is blue, but this star is very hot, nearly 28,000 kelvins estimated by James Taylor. It is about 34,000 times more energetic than the sun. Mimosa is thought to have a radius about 8 times that of the sun and a mass 14 times greater. However, these figures are not certain. Well, everyone, you have been listening to the AICO Carswell Observatory's weekly Teletube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Matt, Maheen, Sergiy, Dhyan, and myself, Arfa. Make sure to leave any comments or questions in the comment section of the video and talk to us in the chat right now. We will be around for the next 20 minutes to answer your questions. All of our programs are free, but if you'd like to make a donation, see our website at observatory.info.yorku.ca. You can always connect with us on Twitter with the handle York Observatory, and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.